Hi everyone, welcome to today's GCSE revision video. There's 5 days to go to your GCSE Maths exam, and today rather than focus on the individual topic, I thought it'd be quite useful to do a recap of all the number topics. So I'm going to go through the number topics on the GCSE Maths paper and go through a lot of the key information that you need to know for. For instance, what are your cube numbers? How do you write things as product or primes? Things like that. So in this video, we're going to do a recap on the number topics. Tomorrow, we're going to go through the statistics and probability topics. The day after, we're going to go through the algebra topics. And the day after that, we'll go through the geometry of the shape, space, and measure topics. So today we're going to focus on the number topics. There'll be lots of information, so remember, if you want to get a pen and paper and write some of this stuff down to remind yourself, feel free, or just sit back, relax, and enjoy the video. So let's get started. Hi, today we're going to be doing a recap of the number topics on the Corbettmaths Revision Checklist, so that's all the topics in red. So in this video I'm going to do a quick recap of all the topics. If you want a more detailed recap of the topics, if you go to the Ultimate GCSE Higher Revision video, from 3 minutes and 13 seconds until 2 hours, 26 minutes and 41 seconds, I cover all the number topics, but in this video I'm going to aim to do a quick recap of all those topics. So in terms of the topics, these are the number topics on the GCSE Higher Revision Checklist on Corbettmaths, so let's get started. Adding fractions. If we want to add fractions, we just need to make sure they've got the same denominators. So if we've got a quarter plus 2/3, we just need to make sure they've got the same denominator. So here, if we've got quarters and thirds, we find a common multiple of 4 and 3, and I'm thinking 12 would be a good choice, so 12 and 12. To get from 4 to 12, you multiply by 3, so we multiply the numerator by 3, so that'll be 3 twelfths, and then plus. And then to get from 3 to 12, we times by 4, so you multiply the numerator by 4 as well. 2 times 4 is 8. So we've got 3 twelfths plus 8 twelfths, that's equal to 11 twelfths. So whenever we're adding fractions, we need to make sure they've got the same denominator by finding equivalent fractions like this. If you've got mixed numbers, make them top-heavy fractions to begin with. So for instance, if this was 1 1/4, you'd make that 5 quarters, and then you'd do the question like that. If it's subtraction, it's just the same, but instead of adding at this point, you would take away the numerators, and that's it. Now, multiplying fractions. Multiplying fractions is quite nice. You just multiply the numerators and multiply the denominators. So if we were to work out 1/7 times 2/3, just multiply the numerators. 1 times 2 is 2. And then 7 times 3, multiplying the denominators, would be 21. So 1/7 times 2/3 would be 2 21sts, and that's it. So to multiply fractions, just multiply the numerators and multiply the denominators, and cancel down at the end if you can. So if we're trying to divide by a fraction, what we actually do is we multiply by the reciprocal. So here, if we had a half divided by 7/8, we take our half, and then instead of dividing by 7/8, we're going to multiply by 8/7. So we just find the reciprocal of this fraction, and in this case I've just flipped it over. And then what we do is we just multiply. 1 times 8 is equal to 8, and 2 times 7 is equal to 14, and this can be cancelled down. We can half both of these to get 4/7. So whenever you're dividing by a fraction, what we do is we multiply by the reciprocal. And again, if you've got mixed numbers involved, just make them top-heavy fractions to begin with, and then do the question as normal by multiplying by the reciprocal. Now let's have a look at reciprocals. So here are some numbers. Let's find the reciprocals. So if we wanted to find a reciprocal of 3/5, you just flip it over, so that would be 5/3. And you can change that into a mixed number if you wanted to. If you've got a number such as 8, you want to find the reciprocal of 8. Well, 8's the same as 8/1, or 8 wholes, so therefore it's reciprocal. When we flip it over, that would be 1/8. Here we've got 1 1/6. Well, if we were to make that a top-heavy fraction to begin with, that would be 7/6. So that's equal to 7/6. And that means it's reciprocal. When we flip it over, would be 6/7. And then if we had 0.75, if we wanted to find the reciprocal of 0.75, we write it as a fraction to begin with, which is 3/4, and then flip it over to find its reciprocal, which would be 4/3. And just remember that a number multiplied by its reciprocal will always be equal to 1. Okay, it's also important that you know how to work out your arithmetic with decimals. So for instance, adding them, subtracting decimals. So if you had something like this, 9.4 subtract 0.75, just make sure that whenever you're lining them up in the columns, that you line up the decimal points. They have all the numbers in the ones or the units column above each other. You have the decimal places lined up, and then you've got the tenths and the hundredths lined up, and then work out the subtraction. If you want to multiply decimals such as this, you could do 9 multiplied by 2 and get that answer. And because you made this number 10 times bigger and this number 10 times bigger, just get your answer and divide it by 10 and divide it by 10 again. So 9 times 2 is 18. If you divide that by 10, you get 1.8. And if you divide that by 10, you get 0.18. Or another way to do it is you could look at the question and see there's 2 digits after the decimal points. So the answer has to have 2 digits after the decimal points. So you could just do 9 times 2 is equal to 18. And then because you know it has to have 2 digits after the decimal place, you could do 0.18. And finally, if you were to work out something like this, 20 divided by 0.2, to do a division like this and divide by a decimal, it could be useful to multiply both of these numbers by 10 to get 230 divided by 2. And the answer to this will be the same as this, because not only is the number that you're dividing 10 times bigger, but the number you're dividing by is 10 times bigger as well, so you get the same answer. And whenever you do work this out, you get that's equal to 115, and that's it. Another thing that's very important is that you know how to use your calculator to do questions. So obviously your calculator display may be slightly different depending on what type of calculator you're using. One thing I would say is make sure you've got a little D on the top of your calculator display to make sure your calculator is in degrees mode, because if you're doing trigonometry, it's very important that you've got it in degrees. Also make sure in terms of your calculator, you know where buttons are, such as the square root button. So make sure you know where the power button is, make sure you know where the squared button is, make sure you know where your brackets are, make sure you know where pi is on your calculator. So make sure where all the key buttons are in your calculator, make sure you're confident with that. Okay, our next topic, estimation. Whenever you're dealing with an estimation question like this, it can be quite useful to round these numbers to one significant figure. So instead of doing 40.18 multiplied by 6.87 and so on, we'd round these numbers to be 40 multiplied by 7 divided by 0.5. And then we just do 40 times 7, which is 280, divided by 0.5, and then we see how many halves go into 280, which would be 560. So the answer there would be 560, and that's it. So whenever we're working at estimation questions, it can be very useful to round the numbers to one significant figure. Okay, another topic you may encounter is best buys. So in terms of best buys, two approaches that I use whenever I'm dealing with best buys is either to take the costs and divide it by the amount. So in terms of these biscuits, we could take the costs and divide it by the number of biscuits in each packet. So you could do 78 divided by 6, and that's equal to 13p. So that means it's 13p per biscuit in that packet. Or here you could take the £1 or the 100 pennies and divide it by 8, and that's equal to 12.5p per biscuit. So as you can see, this packet of biscuit is better value for money. So that's one approach you could use. And in terms of if you've got, for instance, bottles of perfume and you've got so many milliliters, again, you could take the costs and divide it by 50 to find out the cost per milliliter. And you could take the costs and divide it by 75 and find the cost per milliliter and see which one's better value for money. So that's one approach. Or another approach is to find the cost for the same amount. So in other words, for these biscuits, find the cost for 24 biscuits, finding a common multiple here. And likewise for the perfume, you can find the cost for 150 milliliters and find which one's better value for money. Okay, next let's look at currency. So to change into the foreign currency, you multiply here, and then to change back we divide, and that's it. Okay, next, conversion graph. So with conversion graph, sometimes the conversion graph is drawn for you, or sometimes you've got to draw it yourself. Because we know that 1 kilogram is approximately 2.2 pounds, then we'd know that 10 kilograms would be approximately equal to 22 pounds. 0 kilograms would obviously be 0 pounds. So let's plot that one, 20 kilograms and 44 pounds, that would be there. And that's it. So that's how you draw a conversion graph. And then in terms of using it, if for instance you're asked to change 15 kilograms into pounds, you'd go 15 up and across and read off what it is in terms of pounds. If you're asked to change from pounds to kilograms, you'd find where you want to on the pounds and then go across and down. And if for instance you're asked to change something like 200 kilograms into pounds, with 200 kilograms not being on this graph, we'd probably go to 20 kilograms, go up and across, and find out what that is, and then just multiply by 10 and find out what 200 kilograms would be, and that's it. Okay, next we need to be able to write numbers as product of primes. So if we were asked to write 40 as a product of primes, I would do it by writing 40, and then I'd think of two numbers which would multiply together to be 40. So 2 times 20 is equal to 40. 2's prime, so I'm going to circle it, whereas 20's not, so we do another two branches. 2 times 10 is equal to 20, so we circle the 2. 10, 2 times 5 is equal to 10. So we've got all our numbers circled now. We've got 2 times 2 times 2 times 5. So 2 times 2 times 2 times 5 is 40. So 40 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 5. And that's 40 as a product of primes. But we're asked to give our answer in index form. So the answer would be 2 times 2 times 2 is 2 cubed multiplied by 5. And that's it. So 40 is equal to 2 cubed times 5. Okay, next we need to know what LCM and HCF means. So LCM means the lowest common multiple, and HCF means the highest common factor. If you want to find the lowest common multiple of two numbers, such as 7 and 10, you could list their multiples. So you could list the multiples of 7 and list the multiples of 10. If you wanted to find the highest common factor of two numbers, so for instance, if we've got the numbers 15 and 10, what you could do is you could list the factors. And then we just look for the highest common factor. So 1's a common factor, and 5's a common factor, and 5's the highest one. So the highest common factor of 15 and 10 would be 5. That's the largest number they're both divisible by without any remainders. Now sometimes you might need to find the lowest common multiple and highest common factor of some numbers that are a bit bigger. So for instance, if we want to find the lowest common multiple of 20 and 28, so what you can do is you can write both numbers as a product of primes, and then you can do this little diagram. So you'd have here in the middle, you've got two 2's, they both got two 2's, so you can put two 2's in the middle. The 20's get an extra 5, so you put the 5 over there, and the 28's got an extra 7, so put the 7 over there. So we'll put all the numbers in the diagram, and now if we wanted to find the highest common factor, you would do 2 times 2, and that's equal to 4. And if we wanted to find the lowest common multiple, we multiply all these numbers. So we do 5 times 2 times 2 times 7 is equal to 140. So the lowest common multiple of 20 and 28 would be 140. So just remember, if you're doing this diagram to find the lowest common multiple highest common factor, to find the highest common factor, you multiply the numbers in the middle, and to find the lowest common multiple, you multiply all the numbers in the diagram. Okay, next, indices. So make sure you remember your indices. So if you have 5 to the power 4, that's 5 multiplied by 5 multiplied by 5 multiplied by 5. And if you work that out, that's equal to 625. So it's important you know how to work out your indices. Also, make sure you know how to type that into your calculator as well. Also, you need to know your laws of indices. So if you're multiplying things with the same base, you add the powers. If you're dividing things with the same base, you take away the powers. And if you're doing a power of a power, then you multiply the powers together. And that's your laws of indices. So it's important to know those laws of indices. Okay, so we've looked at positive indices, but what if the indices are negative? What if the powers are negative? So first of all, if you get any value apart from 0 to the power of 0, that's always equal to 1. So for instance, if we've got 20 to the power of 0, that's equal to 1. If we had 8 to the power of 0, that's equal to 1. If you've got a negative power, such as 2 to the power of negative 3, you can do 1 over the positive power. So if we had 2 to the power of negative 3, we could do 1 over 2 cubed. 2 cubed, 2 times 2 times 2 is 8, so the answer would be 1 over 8. If we had 10 to the power of negative 2, you could do 1 over the positive power, so just get rid of that minus sign and make it positive, but put it on the denominator, and 10 squared is 100. So negative powers, negative indices, you just do 1 over and then do the positive power on the denominator. Okay, next, fractional indices. So make sure you know how to deal with fractional indices. If you got something to the power of 1 over n, you would then take the nth root of it. So for instance, if we had 36 to the power of a half, we do the square root of 36. Because the denominator is 2, we take the second root of the square root. So the square root of 36 would be equal to 6. So 36 to the power of a half would be equal to 6. If you had something such as 8 to the power of a third, you take the cube root of 8. So the cube root of 8 would be equal to 2. And that's how you deal with fractional powers whenever it's a 1 on the numerator. If you've got something else on the numerator, you then do that power. So if you've got x to the power of m over n, so you take the nth root and then you do to the power of m. So if we had 64 to the power of 2/3, we take the cube root, so we do the cube root of 64, and that's equal to 4. And then we're going to square that, so 4 squared is equal to 16. And that's it. So in terms of fractional indices, what's on the denominator, you do that root, and then what's on the numerator, you then do that power, and that's it. And also if you've got a negative fractional indice, you then just do 1 over at the end, and that's it. Okay, so our next topic is standard form. It's important you can write numbers in standard form. So that's where you've got a number that's bigger than or equal to 1, but less than 10, multiplied by 10 to a certain power. So here we've got 25,000. If we wanted to write that in standard form, we would have 2.5, because that's bigger than or equal to 1, but less than 10. And then we would multiply that by 10 to the power of, and then if we multiply by 10, we get 25. Multiply by 10 again, it'd be 250. If we multiply by 10 again, that'd be 2,500. And if we multiply by 10 again, that'll be 25,000. So we multiply by 4 10, so it'd be 2.5 times 10 to the power of 4. So it'd be 2.5 multiplied by 10 to the power of 4. 1, 2, 3, 4. Now, if we had 0.00009, that'd be 9 multiplied by 10 to the power of. And then when you've got these very small numbers, a bit of a shortcut is you can just count the number of zeros in front of that first digit. So you can just do 1, 2, 3, 4, 5. So it's going to be 9 times 10 to the power of negative 5. And now we've got some numbers here that are written in standard form. Let's write them as ordinary numbers. So if we had 1.2 multiplied by 10 to the power of 8, well, we just move the digits 8 columns to the left. So that'll be 1, 2, and then we'd have 7 zeros. 1, 2, 3, 4, 5, 6, 7. And if we had 1.8 multiplied by 10 to the power of negative 3, we could just put our 3 zeros down, 0.0018. And let's just check that. If we move the digits 3 columns to the right, the 1 would move from here to 1, 2, 3. So there. So that's it. With numbers in standard form, we may be asked to add them or multiply them or divide them and so on. Now, multiplying and dividing them is quite nice because there's a bit of a shortcut with those. But in terms of adding them, if we were given something like this and we were asked to add these, you would write them out in full and then add them and then get your answer and write it back in standard form. So for this one, this would be 5, 3, and then 6 zeros. 1, 2, 3, 4, 5, 6. This would be 7, 9, 6, and then we'd move the digits 2 columns to the left. So we then add 6 zeros. 1, 2, 3, 4, 5, 6. Then you would just add these using a column addition and then get your answer and write it in standard form. So that's how you would add numbers in standard form, and you'd use a similar approach if it was subtraction. In terms of multiplication, if we were to multiply numbers in standard form, such as this, what we can do is if we had 9 times 10 to the power of 4 multiplied by 2 times 10 to the power of 5, you can multiply the 9 and the 2 together to begin with. So 9 times 2 is 18. And then we've got 10 to the power of 4 multiplied by 10 to the power of 5. So remember the laws of indices, you add the powers there. So that'll be 10 to the power of 9. That'll be 18 multiplied by 10 to the power of 9. Now this isn't in standard form. Remember the number at the front has to be between 1 and 10. So what we're going to do is we're going to write 1.8. So we've made this 10 times smaller, so we have to make this 10 times bigger. So that would be 10 to the power of 10. So our answer would be 1.8 multiplied by 10 to the power of 10. In terms of division, well, we'll use a similar approach. If we've got 4.5 multiplied by 10 to the power of 7, and we're dividing that by 9 times 10 to the power of minus 5, we're going to divide these numbers, and then we're going to look at the powers here whenever we're doing this division. So in terms of 4.5 divided by 9, well, if we had 4.5 divided by 9, just using the bus delta method, how many 9s go into 4? 0 remainder 4. How many 9s go into 45? 5. So 4.5 divided by 9 would be 0.5, so we'd have 0.5 multiplied by 10 to the power of, and now here we've got 10 to the power of 7 divided by 10 to the power of negative 5. I remember whenever we're dividing things with the same base, we take away the powers. So we've got 7 take away minus 5. So we've got 7 minus 5. When we subtract the negative, well, we're adding, so we're going to do 7 plus 5, so that's going to be 12. So we'd have 0.5 times 10 to the power of 12, but this isn't in standard form because this number is not bigger than or equal to 1. So we're going to write 5 multiplied by 10 to the power of. And now, in terms of the power, well, we've made this 10 times bigger, so we have to make this 10 times smaller. So if you divided 10 to the power of 12 by 10, well, then you'd have 10 to the power of 11. So the answer would be 5 times 10 to the power of 11. And that's it. So in terms of standard form, it's important you can write numbers in standard form, that you can also write numbers that are in standard form as ordinary numbers, that you can add numbers in standard form, that you can multiply numbers in standard form, that you can divide numbers in standard form. Also make sure you can type it into your calculator, and also sometimes with standard form you might be given a context or a situation, so perhaps the circumference of planets and things like that. So make sure you're aware of how to tackle those standard form questions that involve situations, and the practice questions will be handy for that. Okay, next we've got percentages of amount. So these building blocks will be really helpful for you whenever you're dealing with percentages of amounts without a calculator. And then in terms of percentages with a calculator, one approach is to just divide by 100 and then multiply by the percent you want. So that means that 19% of 240 is 45.6. Another approach is to use a multiplier. So what we could do is if we wanted to find 19% of a number, we could take the 240 and multiply that by 19% is the same as 0.19. So 0.19 is a decimal. So you could just multiply by the decimal, just change the percent to a decimal, and then that's a multiplier. And if you work this out, you get 45.6. And that's it. So in terms of finding the percentage of amounts, you could use a multiplier, or the approach I like to use is just divide by 100 and multiply by the percentage you want. Okay, let's have a look at our next topic, percentage change. So if you encounter the terms percentage change, percentage increase, percentage decrease, percentage profit, percentage loss, and so on, then you might want to use the formula percentage change equals change divided by original times 100. So if we had the height of a plant that increases from 30 centimeters to 46 centimeters, and you've been asked to work out the percentage increase, well, you find the change, well, it's gone up by 16. So the change is 16 divided by the original, which is 30, and then multiply by 100, and you just work that out, and that'll be your percentage change. Just remember, change divided by original times 100. So simple interest is where the interest stays the same every single year. So if we had the question said £300 is invested for 2 years at 10% per year simple interest, what that means is that 10% of £300 is added every single year. So if we work at 10% of £300 is equal to £30. So that means that every single year £30 interest is earned. So over 2 years you would just take your £30 and multiply that by 2, and that's equal to £60. So how much interest is earned? £60. If it was 3 years it'd be £90. If it was 4 years it'd be £120, and so on. If the question said to work out the total amount of money in the bank account, I'd add that £60 onto the 300 and the answer would be £360. But the question just said to work out the total interest, so the answer is £60. So simple interest, the amount of interest stays the same every single year. Now they're not as common as compound interest, so let's have a look at compound interest. So here's a compound interest question. James invests £8,000 in the bank for 3 years and earns compound interest of 5% per year. I've been asked to work how much money he has in the bank at the end of 3 years. So in terms of this question, you could do it manually. You could take the £8,000, increase that by 5%. That's how much you'd have at the end of 1 year. Get that in the amount now, increase that by 5%. That's how much you'd have at the end of the second year. And then take that amount and increase that by 5%. That's how much you'd have at the end of the third year. Or you could use this formula. It's a really useful formula whenever you're dealing with compound interest, but also growth and decay questions. And that's initial multiplied by the multiplier to the power of time. So here the initial amount of money is £8,000. The multiplier, well, it's going up by 5% every single year. So if we increase something by 5%, we'd have 105% or 1.05. So if you want to increase something by 5%, you multiply it by 1.05. That's our multiplier. And then to the power of time, which would be 3. And then you just work that out. So this is a really useful formula. Initial multiplied by the multiplier to the power of time. And that's really useful for your compound interest questions. Okay, next, reverse percentages. So sometimes, rather than increasing something by a percentage or decreasing something by a percentage, you might have a situation where something has been already increased or decreased by a percentage and you have to find the original. So let's have a look at our question. We've got Rebecca's been given a 35% pay rise. She's now paid £13.77 per hour. And the question said, what was Rebecca's pay before the pay rise? So in terms of this question, we're trying to find how much her pay was before the pay rise, so before it went up by 35%. So that's how we know it's a reverse percentages question. So in terms of this question, we could approach it in a couple of ways. So one approach is, she's been given a 35% pay rise. So she would have had 100% to begin with. If you increase that by 35%, you would have 135%. And that's equal to, in this case, £13.77p. Now we want to find what her pay was before the pay rise. That's 100%. So I would divide both of these by 135. So I would divide by 135 and I would divide by 135. That would tell me what 1% is. So I'd have 1% is equal to something, and I would just divide and find out what that is. And then I want to find out what 100% is, so I would then just multiply by 100 and multiply by 100. And if I did that, we find out what 100% is, and that's how much money she was paid per hour before her pay rise. So you just take this amount of money, you divide by 135 to get 1%, and then times by 100 to get what it was to begin with, 100%. Another way to do this question is, if you increase something by 35%, the multiplier would be 1.35. That's how you increase something by 35%. You multiply by 1.35. So to reverse the percentage question, you could divide by the multiplier. So we could take the £13.77p and divide it by 1.35, and then that would be the answer as well. So you could use either approach. Okay, next, recurring decimals to fractions. So it's important to be able to write a recurring decimal as a fraction. And you may be asked to do that algebraically. So you may be asked to write 0.0262626 and so on as a fraction. And I might say using an algebraic approach. So in terms of that, what you would do is what you've been given in the question, this 0.02626 and so on, you call that x. So x equals 0.0262626 and so on. We then want the same recurring but after the decimal point, so let's multiply this by 10. So 10x would be equal to, times this by 10 would be 0.262626 and so on. So we've got 10x, and that's got the 262626. And then if we go back up, if we times this by 1,000, we would get 26.262626. So 1,000x would be equal to 26.262626 and so on. And then we take these away from each other. So we subtract those. We then get 1,000x take away 10x is 990x, and then that's equal to, on this side, we'd just be left with 26. And then we divide by 990, so we get x is equal to 26 over 990, and then you just cancel that down. And that's equal to 13 over 495. And that's it. Ratio is a very important topic, a very important number topic. So there's lots of different ratio skills you need to be able to do. One of them, simplifying ratios. So if you were given something like this ratio, you could just cancel it down. You would get 7 to 10. So that would be this ratio simplified. So you just cancel it down a bit like cancelling down fractions. Okay, now sometimes with ratio we're asked to express things in the form n to 1 or 1 to n. So what we're going to do is we're going to divide both numbers in this ratio by 5. So we're going to divide the left-hand number by 5 and the right-hand number by 5. 16 divided by 5 is equal to 3.2. And then 5 divided by 5 is equal to 1. So we've got it in the form n to 1. We've got 3.2 to 1. And that's in the form n to 1, a number to 1. So we've made the number on the right-hand side 1. Sometimes we're asked to express ratios as a fraction or ratios as a percentage and so on. So here we've got a box containing white and grey beads, and they're in the ratio 2 to 3. So if we wanted to find the fraction of the beads that are grey, so if we consider the ratio, for every 2 whites is 3 greys. So that means white, white, grey, grey, grey. And if we want to find what fraction of the beads are grey, we've got 3 out of 5. So it's just going to be 3 out of 5, and that's it. So if you add together the numbers in the ratio, that's what will go in the denominator. And the number for the one that you want, so in this case the 3 for the grey, goes in the numerator, and that's it. Also with ratio, sometimes you have to share a number in a given ratio. So here Jack and Chloe are sharing £75 in the ratio 2 to 3. And if you want to share something out in a ratio, such as £75 in the ratio 2 to 3, you add the numbers in the ratio. So we do 2 plus 3 is equal to 5. Then we look at what we're sharing out, the £75, and you divide it by that. So we're going to do 75 divided by 5, and that'll tell you how much is in one part. And 75 divided by 5 is equal to 15. So that means there's £15 in one part. So in one part. Now if we have a look, Jack gets 2 parts, so we take the £15 and we multiply by 2, and that tells how much Jack gets, which would be equal to £30. That's for Jack. And in terms of Chloe, she gets 3 parts, so we take the £15 and we multiply by 3. And 15 multiplied by 3 is equal to £45. So that means that Chloe gets £45. So the share quantity in a given ratio, you just add together the parts in the ratio. You then take what you're sharing and divide it by that answer. And then you multiply that amount, that answer, by each of the numbers in the ratio. And that'll tell you how much each person gets. And that's it. Okay, next, sometimes with ratio questions, rather than sharing out the total, they give you one of the values. So here we've got the ratio of lemon sweets to strawberry sweets is 5:3. So for every 5 lemon sweets, there's 3 strawberry sweets. And we're told there's 120 lemon sweets, so we're told one of the quantities, and we want to find out how many strawberry sweets there are. Now you could do this by considering for every 5 lemon there's 3 strawberry, and just then go for 10 lemon there'd be 6 strawberry, for 15 lemons there'd be 9 strawberry sweets, and so on. Or a quick way to do that would be to look at the lemon sweets. There's 120 lemon sweets and divide that by its number in the ratio. So 120 divided by 5, because the 5 parts is lemon. 120 divided by 5 is equal to 24. So there's 24 sweets in one part, and then multiply by the strawberry sweets number in the ratio, which is 3. So 24 multiplied by 3 is equal to 72. So that means there's 72 strawberry sweets in the tub, and that's it. Okay, another useful skill whenever you're dealing with ratios is if you've got 2 different ratios, how to combine it as one ratio. So if we've got the ratio of sheep to cows is 3:4, and the ratio of cows to pigs is 5:2. So we want to find the ratio of sheep to cows to pigs. So I'm just going to write sheep to cows to pigs. And then the first ratio was sheep to cows is 3:4, so that's 3:4. And then in terms of cows to pigs, that's 5:2, so cows to pigs, that's 5:2. And now if we look at these 2 ratios, we've got 2 ratios that involve cows, so let's find a common multiple of 4 and 5. And a common multiple that I'm going to choose is 20, so I'm going to find 20. So if we multiply the top ratio by 5, both of these numbers by 5, we'll get 20 on the right hand side, and so 4 times 5 is 20, and 3 times 5 is 15. And then if we take the second ratio, to get from 5 to 20, we times by 4, so we multiply 2 by 4, that's equal to 8. So the ratio of sheep to cows to pigs would be 15 to 20 to 8, and then that can't be cancelled down, so that's it. Also, it can be useful to write a ratio as an equation. So if we've got the ratio x to y is 3:2, if I wanted to write that as an equation, what I do is I take the x and I multiply by the y number in the ratio, so that's going to be x times 3, so that's 3x, and I put that equal to y multiplied by the x number in the ratio, and y times 2 is equal to 2y, and that's our equation. And we can either make x or y the subject if we wanted to, so we could divide both of these by 3 to get x is equal to 2/3 y, or you could divide both of them by 2, and so on. And if you wanted more of a recap on that, if you watch one of these videos, I think it's 271C, that goes through that in a bit more detail, but that's just a bit of a shortcut in terms of how you'd write a ratio as an equation. Okay, next, direct proportion. So sometimes you might be given a question like this where you got C is directly proportional to the square of D. So C is proportional to the square of D, so D squared. C is proportional to D squared. I've just written down what we've been told. Then we get rid of the proportional symbol and we put in K, so C is equal to K multiplied by D squared, just replacing the proportional symbol with a K, a constant of proportionality. Then we use the pair of information that we're given in the question. So instead of C, we write 200, so 200 is equal to K multiplied by, and instead of D squared, it'll be 2 squared. We then work out 2 squared, that's 4, so 200 equals K times 4, so K is equal to 50, dividing both of those by 4. Now we know K is equal to 50, that gives us, if we put 50 back in here, we get C is equal to 50D squared. And then we could just use this for whatever we want to. So here it says find C whenever D is equal to 5. If you just do 5 squared, get your answer and times by 50, that'll be the value for C. Or if you know what C is and you want to find D, you would just put this equal to whatever C is and then solve that to find D, and so on. Okay, next, inverse proportion. So we've looked at direct proportion, but that's where as one value increases, the other one increases. Inverse proportion means as one goes up, the other one goes down. So we've got T is inversely proportional to the cube of L. So let's write that down, T. And in terms of inversely proportional, because it's proportion, we write down the proportion symbol. Inversely, we do 1 over, and this is the cube of L, so L cubed. Then we get rid of this proportion symbol, so we're going to do T equals, and we're going to put K in, so we multiply this by K, and when you multiply a fraction by K, it will just multiply the numerator by K, so you get K over L cubed. And then you just put in this information, so we've got the T, which is 5, is equal to K divided by 0.2 cubed, and so you get 5 is equal to K divided by 0.008, and if you multiply both sides by 0.008, you get that 0.04 is equal to K. So we've got K, so we just substitute that in, so we get the T is equal to 0.04 over L cubed, and that's it. That's the formula linking T and L. And now we've found the formula, we may be then given a question part B, find T whenever L is equal to 10, or find L whenever T is equal to 40, and so on. So it's also important to know what the proportional graphs look like. So Y is inversely proportional to X, so as X increases, Y decreases. So it's like the right hand side of the reciprocal graph. Now we've got Y is proportional to X, so that would look like that, as X increases, Y increases. Next, Y is proportional to X squared, so that's then the right hand side of the quadratic graph, so it would look like that. And then you've got Y is proportional to the square root of X, and that would just be the square root graph like so. And that's it. So it's important to know what those proportional graphs look like. Okay, also with proportion you may encounter questions like this. So it takes 6 hours for 20 workers to seed 40 acres. How long would it take 10 workers to seed 90 acres? Well, if there was just one worker, it would take 20 times longer. So we find out that it takes 120 hours for one worker to seed 40 acres, but we actually want 90 acres. So let's divide this by 40 and see how long it takes one worker to seed 1 acre. So we've now found out it takes 3 hours for a worker to seed 1 acre. We want 90 acres, so it'll take 90 times longer, so that'll be 270. And then finally, that's one worker. We've actually got 10 workers, so that would take 10 times less time. And that's it. How long would it take 10 workers to seed 90 acres? The answer would be 27 hours. Okay, another topic that you're quite likely to encounter is limits of accuracy. So whenever you're dealing with limits of accuracy, consider the lower bounds and the upper bounds. So let's consider the distance. It's 100 meters to the nearest 10 meters. So in terms of the lower bound for the distance would be 95 meters, and the upper bound would be 105 meters. In terms of the time, it takes 14 seconds to the nearest second, so the lower bound would be 13.5 seconds, and the upper bound would be 14.5 seconds. So we've now found the lower bounds and the upper bounds. We want to find her greatest possible speed. So to find her greatest speed, that's going to be the biggest distance in the smallest time. So speed is equal to distance divided by time. The biggest distance would be equal to 105 meters, and the smallest possible time would be 13.5 seconds. So we do 105 divided by 13.5, and that'll give us the upper bound for her speed. And so that'll be 7.777 and so on meters per second. So that's the upper bound for her speed, and that's it. Another topic you may encounter is error intervals. So here we've got an error intervals question. It says Frank rounds a number y, so there's a certain number y, and Frank rounds it to the nearest 10, and his result is 130. And we've been asked to write down the error interval for y. So y can be any value that's bigger than or equal to 125, because that's the lowest possible number that would round to 130 to the nearest 10, but it would be anything up to but not including 135, and that's it. Now sometimes whenever you do an error interval questions you may encounter this term truncates, and that means whenever you've got a decimal number you just chop it off, you just sort of ignore anything beyond that point. So here we've got Frank truncates a number x to one decimal place. So that means he's got a certain number x and anything beyond the first decimal place he's just ignoring, and his result is 3.1, and we've been asked to write down the error interval for x. So that number x could be anything bigger than or equal to 3.1, and it can be anything up to but not including 3.2, but anything such as 3.19997 you truncate that to be 3.1, so that would be the error interval for x. Another very important topic in GCSE Higher is surds, and here's some rules whenever you're dealing with surds. That if you got root a times root b, it's root ab, so root 3 times root 5 would be root 15. Root a times root a, so a surd times by itself would be a, so root 7 times root 7 would be 7, because it would be root 49, which then when you square it would be 7, so root a times root a is a. And then if you got root a divided by root b, it's root a over b. So in other words, if you got root 6 divided by root 2, that would just be root 3. So it's important to know those rules whenever you're dealing with surds. Also, you may need to simplify surds, so we may be asked to simplify something like the square root of 200. And to simplify a surd, just consider the biggest square number that's a factor of that number. So the biggest square number that's a factor of 200 would be 100. So we'd split this up into root 100 multiplied by root 2. And the square root of 100 is 10, so that would be 10 root 2. Okay, so it's important you can simplify your surds. Also, it's important to be able to add surds. So if you had something such as root 18 plus root 8, what you would do is you'd simplify both of these surds, and then if you simplified both of them, you would get 3 root 2. This would be root 4 times root 2, so that'd be 2 root 2. And then if you add them together, 3 lots of root 2 plus 2 lots of root 2 would be 5 lots of root 2. So if you've been asked to add or subtract surds, you need to simplify it, and then you should end up with the same root 2 part or root 3 part or whatever, and then you just add them or subtract them. You also may need to be able to answer questions that involve squaring brackets involving surds. So something such as this: expand and simplify 3 minus root 2 close bracket squared. And to do that, we just need to remember when we square something, we multiply by itself, so it's going to be, and then you just expand it. And then if you simplify this, 9 plus 2 is 11, and then you've got minus 3 root 2 minus another 3 root 2, so it'll be minus 6 root 2. So the answer would be 11 minus 6 root 2. So we've expanded and simplified this. Okay, next. Now, whenever you're dealing with surds, you may be asked to rationalise the denominator. So if you've got a fraction with a surd on the denominator, you may be asked to rationalise that denominator. We tend not to want an irrational number on the denominator. So if you were asked to rationalise the denominator of 10 over root 2, you just multiply both the numerator and the denominator by root 2. So you multiply both the numerator and denominator by root 2. 10 times root 2 would be 10 root 2, and root 2 times root 2 would be the square root of 4 or 2. So it'll be 10 root 2 over 2, and 10 lots of root 2 divided by 2 would be 5 lots of root 2, and that's it. So you multiply both the numerator and the denominator by the surd on the denominator. And then if you get something like this, 3 over root 2 plus 1, you times both the numerator and the denominator by the conjugate of this. And what that means is, if you multiply both the numerator and denominator by the conjugate of this, so in other words, you change the plus sign to a minus sign, and then you just expand your brackets here, and then you'd be able to simplify it, and that's it. That's how you rationalise the denominator. And our last topic is the product rule for counting, and this is really useful useful to find out how many possible combinations of things there may be. So here we've got a situation such as Grace picks a 4-digit number for her lock. The first digit is a prime number. The third digit is greater than 7. And we've been asked how many different 4-digit numbers can she choose. So in terms of the first digit, she could have 2, she could have 3, she could have 5, or she could have 7. So there's 4 different possible prime numbers she could have in that digit, that first digit. So there's 4 possible numbers there. In terms of the second digit, it can be anything. We're not told anything about the second digit. So there's 10 possible options there, 0 all the way up to 9. The third digit is greater than 7, so that's an 8 or a 9. They're the only 2 digits that are greater than 7, so there's 2 options there. And the fourth digit, it doesn't say it's odd or even or anything like that. So it means for the fourth digit, there's 10 options as well. We can now just multiply those together, and that'll tell us how many possible choices you can have. And that's equal to 800. So it means there's 800 possible 4-digit numbers that Grace can choose with those rules. And that's it. So in this video, we've gone through our number topics. Well, our first topic was adding fractions. So whenever we're adding fractions, just make sure that they've got the same denominators by finding an equivalent fractions before you add or subtract those fractions. If you've got mixed numbers, it can be very useful to make them top heavy fractions before you begin. Multiplying fractions, just multiply the numerators and multiply the denominators. If you've got a mixed number, again, make it a top heavy fraction before you begin, and then just multiply the numerators and denominators. Dividing fractions, well, what we do is we multiply by the reciprocal of the fraction we're dividing by. Reciprocal, well, if you've got a fraction, you just flip it over. Remember, a number multiplied by its reciprocal is equal to 1. Decimals, make sure you can order decimals, add decimals, subtract decimals, multiply decimals, divide decimals, things like that. Use of a calculator, make sure you know where all the important buttons are in your calculator. Make sure it's got a little d at the top for degrees, and also make sure that you know where sine, cos, tan, you know how to do your brackets, your roots, your powers, and things like that. Make sure you know how to use your calculator. Estimation, it can be very useful whenever you're doing estimation questions to round the numbers to one significant figure. That can be quite useful. Best buy, so in terms of best buys, you might want to divide the cost by the amount to find perhaps the cost per biscuit or the cost per milliliter and so on, and then compare them. Or you might want to find the cost for the same amount. Currency, to change into the foreign currency, you multiply by the number in the exchange rate, and to change back you divide as long as it's £1 equals so much. Conversion graphs, make sure you know how to use conversion graphs and how to read off conversion graphs and draw them as well. Product of primes, make sure you know how to write a number as a product of primes by thinking of the numbers, circling any prime numbers and so on. And if the question says to give your answer in index form, make sure you're writing it in index form with those powers. The lowest common multiple, highest common factor. If you want to find the lowest common multiple, you can write down the multiples of the numbers and find the lowest common multiple. Alternatively, you could do your product of primes, do your circles, put the prime numbers in, and for lowest common multiple, you just multiply all the numbers together, and then that will be your lowest common multiple. And for the highest common factor, you could list down the factors of two numbers, for instance 15 and 20, you could list down their factors, and then the highest common factor would be 5. Alternatively, you could do the product of primes, so if the numbers are trickier, you could do the product of primes, and then do your circles, put in your prime numbers, and then just multiply the numbers in the middle. Indices, make sure you know how to work out powers, so for instance 5 to the power 4 would be 5 times 5 times 5 times 5, and you'd work that out. Make sure you know how to type indices into your calculator, and make sure you know your laws of indices. When you're multiplying things with the same base, you add the powers. When you're dividing things with the same base, you take away the powers. When you've got a power of a power, you multiply the powers, and so on. Negative and fractional indices. So remember that anything to the power of 0 apart from 0 is equal to 1. Negative indices, if you've got a negative power, so for instance if you've got 5 to the power of negative 2, you do 1 over the positive power, and 5 squared is 25, so that'll be 1 over 25. So that's how you work out negative powers, you do 1 over the positive power. If you've got fractional powers, for instance the power of a half means square root, to the power of a third means cube root, to the power of a quarter means the fourth root, and then if it's got a numerator other than 1, you then do that power. So for instance if you get to the power of 2/3, you would do the cube root and then square it. Standard form, make sure you know how to write numbers in standard form. So a number in standard form will have a number that's bigger than or equal to 1 but less than 10, multiply by 10 to a certain power. Make sure you know how to add and subtract numbers in standard form. Make sure you know how to multiply and divide numbers in standard form, and make sure you're confident in terms of tackling standard form questions which may be in a context. Percentage of amounts, make sure you know how to work out percentages of amounts without a calculator, but also with a calculator. Divide by 100 to find 1% and then multiply by the percentage you want. Alternatively, you could use your multiplier. So for instance if you wanted to work at 62% of a number, you could just multiply by 0.62. If you wanted to increase by 7%, you could multiply by 1.07. In terms of percentage change, remember that's change divided by original times 100. Simple interest, remember that's where the interest stays the same every single year, so you just work out, for instance if it was 10% simple interest per year, work out 10% to begin with and then just add that amount on every single year. Compound interest, well if it's a calculator question I would definitely use initial multiply by the multiplier to the power of time. If it's a non-calculator question then you just do it manually. So for instance if you had £500 invested in the bank at 10% compound interest for 2 years, you get the £500, you increase it by 10% to get £550, and then you increase that by 10% to find out how much you'd have at the end of the second year. In terms of reverse percentages, if something goes up by 7%, you'd have 107%. Then you just know that 107% equals such and such. You then divide both of them by 107 to find 1%, and then times by 100 to find the original amount. Alternatively, you could divide by the multiplier. Make sure you know how to write recurring decimals as fractions, so let it equal x, find perhaps 10x or 100x or 1000x. As long as the bit after the decimal points are identical, you can then subtract them, and then they'll cancel out, and then you can then write it as a fraction. Ratios, make sure you know how to simplify ratios, write things in the form of 1 to n and n to 1. Make sure you know how to write a ratio as a fraction or a ratio as a percentage. Make sure you know how to share a total out in a given ratio. Make sure you know how to do ratio questions if you're given one of the amounts. Make sure you know how to write two ratios and combine them as one ratio. And also make sure you know how to write ratios as equations and equations as ratios. In terms of direct proportion, remember your little fishy, the little proportion symbol. Write down what it tells you in the question. So if it says a is directly proportional to the square root of b, you'd write a is proportional to the square root of b, and then replace that proportional symbol and put the k in. So it equals a equals k times the square root of b, and then you just use the values for a and b to find k, and then that gives you your equation, and then you can use that to work out the answers to other bits of the question. So in terms of inverse proportion, so you may have something such as a is inversely proportional to b squared. So then whenever it's inversely proportional, you put 1 over. So you'd write a is proportional to 1 over b squared. So inversely proportional, you put 1 over whatever it tells you in the question. In terms of applying proportion, make sure you're confident with those questions involve time and how to do a proportion in those situations. Limits of accuracy, make sure you know how to find the lower bound and the upper bound, and then perhaps use them in questions as well. Error intervals, make sure you can write error intervals for whenever you're rounding things, but also truncating things. Okay, next, surds. Make sure you know the rules whenever you're dealing with surds. So root a times root b is equal to root ab. Root a divided by root b would be equal to root a over b. And also know that root a times root a is equal to a. Also know how to do things such as simplify surds, add surds by simplifying them first and then adding them. Know how to multiply surds, divide surds, and also know how to rationalize denominators. And also make sure you're confident with product rule for accounting. Remember, the product rule of accounting is really useful to work out how many possible options or combinations there may be. And I would highly recommend the practice questions there for a bit of practice in those as well. And that's it. So in this video, we're focused on doing a recap for the number topics from the GCSE Maths paper. So keep up the hard work. You're doing really well. Tomorrow, we're going to go through the statistics and probability topics. So look out for that one. And yeah, so I hope you found this video useful. Cheers. Bye.